Hello class, today we are going over the lesson we did in class on August 15, 2019 or August 16, 2019 depending what period you are in. We started Unit 1. You should all have your handouts with Unit 1 and we started subchapter 1.1 which is properties of algebra and evaluating expressions. The notes that we took during class are available in your Google Classroom, so you can visualize them there. We will just go over the parts of the handout that we went over in class. We started with page number 2 with the properties of algebra. And we filled out this table together. So please put a plus sign or write addition. So you know the left-hand column pertains to the properties of addition. The right-hand column pertains to multiplication. Then we will go over each property. The first one is the identity property. Identity of addition and identity of multiplication. When you think of the identity property, think of the word identical. This means we start with a number or value and end up with the same number or value. In the case of addition, we are adding something. So in order to get the same value, we have to add a 0. So 10 plus 0 gives me the identical number, which is 10. Similarly, for a variable, if I have x plus 0, I get the same identical value, which is x. For multiplication, if I have 10 times a certain value, I have to end up with the identical value I started with. In this case, I have to multiply by 1. So my identity is 1. 10 times 1 equals 10. If I have a negative, similarly, if I want to start with negative 3 and end with negative 3, that means I have to multiply the identity, or 1. For x, the same thing. X times 1 gives me x. Next property is the inverse property. Inverse of addition and inverse of multiplication. What you add to a number to get 0. So in this case, I start, let's say, with 10, and I have to end up with 0, which was, remember, my identity in the previous property. So what do I have to add to 10 in order to get 0? I have to add its inverse in addition. The inverse of 10 in addition is negative 10, or the opposite of 10. If I start with negative 10, what do I have to add to get 0? Now I have to add positive 10. Same for the variable x. If I want to get to get 0 in the end, I have to add its opposite, which is negative x. For multiplication, similarly, I start with a number. So let's say 3 over 2. I have to multiply something to that number to get 1 this time. Remember, 1 is the identity of multiplication. In this case, I have to multiply its reciprocal. If you remember from middle school, the reciprocal of a fraction is simply that fraction flipped. So the reciprocal of 3 over 2 is 2 over 3. When I multiply 3 over 2 times 2 over 3, the 3's simplify, The 2's simplify and I get 1. How about 5? What is the reciprocal of 5? Well, I can write any number as a fraction. So I can write 5 as 5 over 1. And I multiply it by its reciprocal, which is flipped 1 over 5. In this case, the 5 simplifies and I get again 1. So the inverse of multiplication is the reciprocal of the fraction or the fraction flipped. The next property is the commutative property. The commutative property of addition and the commutative property of multiplication. When you think of the word commutative, please think of the word to commute, which means to change places. So this property tells us that the order in which terms are added does not affect the sum. This is for addition. So let's take an example. 4 plus 5 plus 6 gives me the exact same result as 4 plus 6 plus 5. So as you noticed in this case, the numbers commuted, 5 and 6 commuted, which means 5 and 6 changed places. Instead of 5 plus 6, now I have 6 plus 5. So if the numbers physically change place, that example illustrates the commutative property. Another example, let's say 1 plus 2 plus x plus 3 will give me the same result as x plus 2 plus 3 plus 1. We see every number in this example is still the same. They just changed places. They are no longer in the places they started with, but I still get the same sum. Similarly, in multiplication, the order in which terms are multiplied does not affect the product. This means that as long as I have the same numbers, if they change places or commute, this does not affect the product. So for example, 4 times 5 times 6 will give me the same result as 5 times 4 times 6. As you notice, now almost all of the numbers, well, 4 and 5 have changed places. Instead of 4 times 5, now I have 5 times 4. All that happened is that 4 and 5 commuted or changed places. Another example, 2 times x times 5 gives me the same result as 5 times 2 times x. The numbers commuted, but the result will be the same. Next property is the associative property. Associative property of addition and associative property of multiplication. When you think of the word associative property, please think of the meaning of associate. If I say, I am going to lunch with my associates today, that means I'm going to lunch with my group of friends or acquaintances. So to associate means to group. The property says that the way terms are grouped when adding does not change their sum, or the way terms are grouped when multiplying does not change their product. So let's take an example for addition. 4 plus 5 plus 6 gives me the same result as 4 plus 5 plus 6. It is important that you know the difference between associative and commutative. To commute means to change places. So you notice in the commutative property, the numbers physically change places. In the associative property, the numbers have not moved. 4, 5, 6 are still in the same spots. What did change is the parentheses. I want you guys to remember that the parentheses is a symbol for grouping. So to associate means to group. So what changes in the associative property is the groupings or the parentheses. The same for multiplication. 4 times 5 times 6 gives me the same result as 4 times 5 times 6. Again, what changed in this example is the parentheses and not the place of the numbers. And the last two properties, on the left side we have the distributive property. To distribute a number or factor by multiplication to all terms within parentheses. To distribute means to give out, to share. So let's take an example. Let's say 2 times 3 plus 4. So let's think of the meaning of the word to distribute. When I say I'm distributing something to you, it means everybody gets one. Similarly, if I'm distributing 2 on the inside of the parentheses, every term inside the parentheses gets a 2. So I have 2 times 3 plus 2 times 4. The 2 is distributed to every term inside the parentheses. 2 times 3 gives me 6 plus 2 times 4 gives me 8. 6 plus 8 gives me 14. And the last property, it's also the easiest property, is the multiplicative property of 0. It has the longest name, but it is the easiest property. Multiplicative property of 0. Any number multiplied by 0 equals 0. Very straightforward. So if I get 4 times 0, that will give me 0. Let's take a negative. Negative 3 times 0 also gives me 0. X times 0 gives me 0. Any number multiplied by 0 equals 0. The next thing that we did in class was go over page 3 of the handout, and we started with solving problem 1. Define each property, then match the properties to the examples given in the next column. I will just trace an arrow from the property to the example because the examples are a little bit off. So I want to know exactly what answer I get for each property and not make a mistake. And now that I've done that, I will read each property and try to find what example matches. You can start from the right-hand column as well. I chose to start from the left. So the multiplicative property of 0. Multiplicative tells me I'm looking for multiplication. Property of 0, it tells me I'm looking for a number that multiplies with 0 to give me 0. Do I have such an example? Yes, I found it right away. Is A. 3 times 0 gives me 0. Next one, the additive identity. Additive tells me I'm looking for a plus sign or addition. Identity tells me I start with a number and end up with the same identical number. So what do I have to add to 10 to get 10? I have to add 0. So let's look at the examples. I see I looks like that. I start with 12 and I end up with 12 by adding 0. Next one, the multiplicative identity. The word multiplicative tells me I'm looking for multiplication. Identity tells me I start with the number, end up with the same identical number. So in this case, I have to multiply by 1. So if we look in our examples, there is only one example where I start with the number and end up with the same number. That is F. I start with 12 and I end up with 12. But how about x to the 0? If you remember from middle school, any number raised to power 0 gives me 1. So if I have 3 to power 0, that is 1. 5 to power 0 is 1, and so on and so forth. Any number to power 0 is 1, even a negative. Negative 1 to power 0 is positive 1. So this is F. The next property is the additive inverse. The word additive tells me that I'm looking for addition or plus sign. Inverse tells me that if I start with a number, I have to end up with 0. So for example, to 10, I would add its inverse in addition, which is negative 10. By looking at the examples, we notice that E is the example we're looking for. We start off with negative 6, and we add its opposite in addition, or its inverse, which is 6, to end up with 0. So it is E. The next one is the multiplicative inverse. The word multiplicative tells us we're looking for multiplication. And inverse, the inverse of multiplication is the flipped fraction. So if we start off with 10, the inverse or flipped fraction of that is 1 over 10, which gives us 1. By looking at our examples, we see that D looks very similar to this example. So in D, we start with the number 1 over 5. And when we flip that fraction, we get 5 over 1, or 5. 1 over 5 times 5 gives us 1. So that is the multiplicative inverse. The next property is the commutative addition. The word addition tells us we're looking for the plus sign. Commutative means to commute, to move places. So we're looking for numbers or values that have changed places and that are added. So let's look at C. If this was a little bit confusing because we have 5 times, because we're looking specifically for the commutative addition property, we can ignore the 5 times. So we're looking only at y plus 3 and 3 plus y. Have the numbers stayed in addition? Yes, so it is an addition property. Have the numbers changed places? Yes. Instead of y plus 3, we have after the equal sign 3 plus y, so the numbers have commuted. So this is the correct property. The next property is the commutative multiplication. So now we're looking for the multiplication sign, and we're looking for numbers that changed place. So for example, 3 times 4 equals 4 times 3. So let's look at J. In this example, we do have multiplication. How about commutative? Have any numbers or values change place? We notice x times y changed place, and after the equal sign became y times x. So they did commute. This is J. The next property is the associative addition. Addition tells us we're looking for the plus sign. And associative tells us the word associate, to group. We're looking for grouping symbols, such as parentheses. In this case, none of the numbers or value commuted, so the only thing that changed is the parentheses. So let's look at B. Is B addition or multiplication? Since B is multiplication, that is not our example. Let's look for one with addition. So let's look at G. In G, have any of the values changed place? No, we started with 287 and we end up with 287. None of them changed places, so they did not commute. What did change was the parentheses. First, we had 8 plus 7. So 8 plus 7 were in a grouping together, or they were associating. Now, after the equal sign, we have 2 plus 8 in a grouping together. So it is G. Next one, associative multiplication. In this case, we're looking For the multiplication sign, so let's look at B this time. We do have multiplication. Have the values moved? Have they commuted? No, they stayed with where they are. What did change was the parentheses or the grouping symbol. Therefore, this is the associative multiplication property. And the last one, what is left is H. The distributive property. In our case here, we took 3 and distributed the 3 on the inside of the parentheses. And we got 3 times x plus 3 times 2, which is 6. The next thing we did in class were examples 3, 4, 5, and 6. So let's do those quickly together. For number 3, we're distributing 6 on the inside of the parentheses, and we get 6 times 4 plus 6 times 5 equals 6 times 4, because we're doing the multiplication first, order of operations. 6 times 4 is 24, plus 6 times 5 is 30. Last thing we do is the addition, and we get 54. Number 4 tells us again to distribute. So we take that 8 and distribute it on the inside, and we get 8 times 4 plus 8 times 3x. Equal order of operations, we do the multiplication first. 8 times 4 is 32, plus 8 times 3, 24. Don't forget the x. In this case, we are done because we cannot add a term with x in it with a term with no x in it. So we are done. For problem 5, we have a typo. Here we should have 3a squared plus 2b plus 2c squared. So here we have to evaluate, which means we have to replace our unknowns or variables with the given values. To do this, I like to rewrite the expression with blank spaces or parentheses where my variables are. And then I replace. Instead of a, I have -1. Instead of b, I have 4. And for c, I have 6. Order of operations. I start with the parentheses. There's nothing for me to do inside of the parentheses, so next thing I do is exponents. 3 times -1 squared gives me -1 times -1, which is +1, plus 2 times 4, plus 2 times 6 squared gives me 6 times 6, which is 36. Order of operations, next thing I do is the multiplication. 3 times 1 gives me 3, plus 2 times 4 gives me 8, plus 2 times 36 gives me 72. Order of operation, next thing I do is the addition. 3 plus 8 is 11, plus 72, which gives me 83. And the last one on page 3 is problem 6, which also has a typo, so please change this to 3a minus 4b squared plus 2c. Again, I will rewrite the expression by leaving blank spaces or parentheses wherever I have a variable, copying everything else exactly as it is. So where I have my first blank space, I will put the value of a, then the value of b, and the value of c. Order of operations, the next thing I do is parentheses. Inside the parentheses, everything is solved. Then I move on to exponents. I have one exponent, so I do 3 times -1 minus 4 times. 4 squared is 4 times 4, which is 16, plus 2 times 6. Order of operations, next thing I can do is the multiplication. 3 times -1 gives me -3, minus 4 times 16. I can do this on the side if I don't have a calculator or don't know how to do this on the spot. I align the numbers starting from the right. 4 times 6, 24. I remember a 2. 4 times 1 is 4, plus 2 is 6. So I guess 64. Plus 2 times 6 is 12. Order of operations, next thing I do is addition and subtraction. -3 minus 64, because I have two numbers with the same sign, I keep the sign and add. 3 plus 64 is 67, plus 12. -67 plus 12, when I have opposite signs, a negative and a positive, I subtract. So I do 67 minus 12, which gives me 7 minus 2 is 5, 6 minus 1 is 5. I get 55, but be careful with the signs. Keep the sign of the largest absolute value, meaning if you ignore the signs, which number is larger? 67 is larger, so I keep the sign of 67, which is a negative. On page 4, we are going again over some of the same notes we took in class. Here I highlighted what you really must know: the definition of evaluate and the order of operations. These were also part of your notes. If you are missing those notes or want to look over them again, they are uploaded into your Google Classroom. So these here that are yellow, underlined with yellow, you have to really pay attention and learn those because they might be on your test. So now let's solve the 3 examples that we did in class. Number 1, it says evaluate the following expression when x equals 3. That means we take the 3 and replace it where it says x, and we get 3 plus 6 equals 9. And we are done. Example 2, again, to evaluate the following expression when x equals -4. So I will rewrite the expression, and instead of x, I'll plug in a -4. 2 times -4 gives me -8 plus 5, which gives me, remember, when the signs are opposite, we subtract and keep the sign of the largest absolute value. The largest number between 8 and 5 is 8. 8 is a negative, so I keep that negative, and I subtract the 2. 8 minus 5 gives me 3. So the end result is -3. Example 3, evaluate the following expression when x equals 4 and y equals -2. Again, I will rewrite my expression, leaving blanks for the variables, and then plug in 4 for x and -2 for y. Order of operations, my parentheses are done, nothing for me to do, and I move on to doing the exponents. So I get 2 times 4 squared is 4 times 4, which gives me 16, plus 3 times -2 minus 12 equals. Then order of operations, I do the multiplication. 2 times 16, I get 32. 3 times -2 gives me -6 minus 12. And last thing I do, order of operations, the subtraction. 32 minus 6 gives me 26 minus 12, which gives me 14. And the last thing we did in class was work independently or in groups on our classwork problems. Remember, your classwork has to be completed by the end of the unit. So we still have a few weeks until we finish Unit 1, but by then you have to have all of your classwork done. So if you're behind with a few problems, please either complete them at home or during the next time allotted for classwork. I will not solve all of these problems for you as it is your responsibility, but I will solve number 6 and number 10 together with you. So let's try number 6. I will rewrite my expression with blanks or parentheses and then substitute. The first variable was y, which is 7, and the second one is also 7. Order of operations, let's do the exponent. So I have 7 squared, which is 7 times 7, which is 49. Minus 7, 49 minus 7 gives me 42, and I am done. For problem number 10, again, I will rewrite my expression with blanks or parentheses and then replace with the given values. The first variable was q, which is given as 3. The second one was m, which is given as 8. And the third one is also m, which is 8. Order of operations, I do not have anything to solve inside parentheses. I do not have any exponents, so I move on to doing the multiplication. 6 times 3 gives me 18, plus 8 minus 8 equals. Then I move on to the addition. 18 plus 8 gives me 26, minus 8 equals 26 minus 8 gives me 18. Final answer. Here, it doesn't matter, remember, it doesn't matter the order in which I do addition and subtraction. So in this case, I could have done 8 minus 8 first. 8 minus 8 cancels out and gives me 0. So right away, I get 18 as my answer. So either one gives you the same answer. Just one of them is faster. And the last thing we talked about in class, I gave you homework sheet. The homework is due the week of August 19. Thank you so much for watching. Have a nice day.